Yeah. Yes, it's like, darn, you having a good weekend? I didn't realize you did.
It is, yeah. It was
Okay,
blue.
yeah. Yeah. A little bit something.
Any questions from your homework of 2.6 or 3.1?
Any of those we should look at?
49,
Was that on 3-1?
165. Oh, wait. I'm sorry. It was. Wait, yeah, it was. It was 49.
Is that right?
Yeah.
F of X equals 1/4 X to the 4th. Minus X squared. And they say find points on the graph of f where the slope of the tangent is equal to negative 2x, 0, and 10. So we need to find f prime and then set the
Well, I found that. It was just the points that I didn't. And I even got the equation of the tangent and all that, but is x to the third minus x squared minus 2x minus 12? Oh, wait, that's not right. Wait.
Was that the function?
No, that
So
was
that-
not.
So
That was
would
the
be,
derivative, I'm sorry.
that's the derivative. And the part A said, when is that slope of the tangent equal to negative 2x? All right? So for part A, we would say, when is x cubed minus x squared minus 2x equal to negative 2x?
It wasn't more.
And then we have to solve for x.
Oh,
So if I add 2x, I would get x cubed minus x squared equals 0.
For some reason, I wrote more of an equation initially. That's why I'm wrong on everything.
Well, yeah, if we
I
solve
messed
this,
up the problem initially.
if we solve that now, would that be correct? And then if you set each factor to 0, x would equal 0 or x would equal 1. And those ordered pairs would be, if x is 0 on that curve, y would be 0. And if x is 1, 1/4 minus 1/3 minus 1.
Okay.
Oh, here this comes. It's just now opening my documents. It's so slow. I thought Mr. Bryce would have brought that up and it would be warmed up, rearing to go. And it wasn't. So, come on. That's just a boy. I can move right over here, can I? Just as easy. Here it is. Okay. So, and it's not going to let me finish. Got this. Let's see. That and that. If I plug 1 in to f, I would get 1/4 minus 1/3 minus 1. With a common denominator of 12, that would be 3/12 minus 4/12 minus 12/12, right? 3 minus 4 is negative. Is that negative 13/12? And so would those be my two ordered pairs that they were talking about?
I wrote the problem wrong.
For parts B and C, you would just put 0 here and then put whatever else they said for part C there and solve for those x's and then find the ordered pairs. That was sort of a multi-step problem, wasn't it? So, but that's all they wanted you to do. Were there any others you had trouble with that I had assigned? You feel pretty comfortable with finding basic derivatives, finding equations of tangent lines at a certain point? So if I asked Wednesday on a quiz, you would say, yes, I can do that, and there's no comment, is there? But we'll practice one. Well, today will actually give us more practice on those concepts, except it takes us a step further. So if you don't have any other questions, let's go ahead and look at page 177. You remember last time we stressed, like in this problem, to find derivatives, we were mostly using the power rule, weren't we? Remember the power rule? Where we bring the power in front as a coefficient and then drop the exponent by 1? That was a nice, easy rule, wasn't it? What if they got a little more complicated? You're not going to be upset, I hope, because they do get a little more complicated. It's not bad, as long as we think about it and remember how to do these. What if I said you had a product or quotient of two functions, f of x times g of x or f of x divided by g of x, and I said, how would you find their derivatives? There are rules for that, and I would like to show you those rules. And these are on D2L, if you would like. The first one is called the product rule. Move this. If you want to take the derivative of f of x times g of x, this is the way you should remember it. That looks like a lot of notation, doesn't it? All you have to do is take the original first function times the derivative of the second plus the derivative of this first function times the original g of x second function. Does that sound like something you could remember? First times second prime plus first prime times second. And that will give you the derivative of a product of functions. Okay? You might say, well, I'm sure it works, it's a rule, but where did it come from? The book is very nice about deriving this for you using our limit as h approaches 0 definition, but there's a lot of algebra tricks involved in it, and it's sort of long. But if you'd like to look at how they derived this from the limit definition, you feel free to look. It's right in your book. Okay? And I don't want you to think I'm just coming up with these like magic. They are derived, and they work. Right? But I won't make you derive them. So, okay, but they're derived from our definition of derivative. So why don't we practice one of these? Now, can you say this to me now? To find the derivative of a product, you take first times second prime plus first prime times original second. Good. Good, you know it. I like it. So,
Two different things.
number 8, to me, is a good example to show this. No, 6. Sorry, 6. Sorry. Number 6 says f of x is x plus 1 times x, 2x squared minus 3x plus 1. You notice that is a product of functions, isn't it? Some of you might say, well, why can't I just distribute that out and do it like we did in the last section? You could, but it might be quicker if we know this product rule. So if I want to use the product rule to find f prime of x, I've covered it up, but do you remember what did it say? Didn't it say the first times the derivative of the second, which would be what?
4x minus 3.
Great. Plus the derivative of the first, 1, times the original second. Well, of course, your book is not going to leave it like that. Your book's going to distribute that out and give you an answer in simplest form, right? So we would have to say this is 4x squared minus 3x plus 4x. So that would be plus x minus 3 plus 2x squared minus 3x plus 1. Give me a good final answer then if I combine them.
6x squared minus 2x minus 2.
I like it. Here's my derivative. Okay. If we distributed all this out and had just one big polynomial and took the derivative of it, we should get the same thing we got. So that's great. But do you understand how we got the product rule? We used that, and that would be the derivative. Unfortunately, of course, the book does not leave it like this. They distribute, and some of these get ugly again, and I apologize that you have to do all this simplifying to get the answer they get, but it's good practice for algebra, isn't it? So, okay. Would it bother you if it looked like 14?
Yeah.
Yeah, I'll look at it.
14 says f of x is x cubed plus 2x plus 1 times 2 plus, how could I write 1 over x squared without the fraction?
1
X
x to the
negative
7.
Would that be good? Would you agree that's 1 over x squared? And then I can use my power rule for that part of it. So if I wrote my 1 over x squared like this, I'm going to be in better shape, right? So now, help me out again. By the product rule. The product rule says, first, what's derivative of second? Okay,
2x to the negative 3.
okay, I'll take that. Okay, plus derivative of first
3x squared.
plus 2 times original second. Now, of course, when we distribute, it's not going to be pretty for a minute, is it? If I distribute that negative 2x to the third, would you agree the first product is just negative 2? Because the 3 plus negative 3 would give x to the 0. Then, that would be minus 4x to the negative 2, wouldn't it? Minus 2x to the negative 3 plus 6x squared plus 3
Plus
3. Is that right? Plus 4 plus 2x to the negative 2. Double check me there. Unfortunately, once again, we're sort of stuck with simplifying. Would you say that 3 plus 4 is 7 minus 2 is 5? Does that sound good? Minus 4 over x squared, if I drop that negative exponent back down, minus 2 over x cubed, plus 6x squared, plus 2 over x squared. Now, what would these two? These two are like. What if I add those two?
2 over x squared.
Yes. 5 minus 2 over x squared minus 2 over x cubed plus 6x squared. And aren't you going to be angry if the book made that one fraction with a common denominator? Makes you go that extra step? I'm fine with what I put a box around. But what if they said, make them all have a denominator of x cubed and make one big fraction? Expect that. But I'm saying on a quiz, I would say, you're right at this point, but I would prefer you do a little simplifying. But I don't want you to spend a whole day just simplifying things, right? But why would we want to simplify? Well, if I had to plug a value into this, I don't want to plug in an x for all this, do I? I would rather plug it into just fewer terms. But I would say that if I plug the x's in here, it would be about the same difference if you made it one fraction. So that's where I'm coming from. Do you think that on Wednesday you could do one of these by product rule if I gave it to you? If I said find f prime of something like that, you could do it. Are you ready for quotient rule? You might not like quotient rule, but I like it. Let's see. Come on. Here is your quotient rule. If you have f of x divided by g of x. Let's see. so slow. Oh, good grief. Come on. Here we go. This is called the quotient rule. That looks even worse, doesn't it? If you want to find the derivative of f of x divided by g of x, I would not try to memorize this. That looks like a lot of notation. I would memorize these words. You take the denominator, which is g of x, times numerator prime, f prime, minus what? Numerator f of x times denominator prime, all divided by what? The denominator squared. Do you think you could remember it in those words? That's the way I remember it. If I think quotient rule, I say, okay, denominator times numerator prime, then reverse it, minus numerator times denominator prime over denominator squared. It's all these little devices, right, in math to help you remember. Okay. That's the way I would remember the quotient rule. And that is what it's called. Okay. I picked out number 16 for us to try first by the quotient rule. Is it okay if I cover this up? You got it? 16 says g of x is 3 over 2x plus 4. There we go. Okay. So let's see, if we want to find g prime of x, I'm going to make my big fraction, and I'm going to say, what? Denominator times numerator prime, which is 0, I like that, minus numerator times denominator prime, is that right? Over what? Denominator squared. Let's say it again. Denominator times numerator prime minus numerator times denominator prime over denominator squared. This is not bad. What's your answer?
-6
And that's fine. That's great. Do you think they're always going to be that pretty? No. Ugly, ugly. Okay. That 0 wiped out that whole first term. That was nice. Why don't I give you a minute to try 22 by the quotient rule? See if you can get it. 22. What's horrible is you'll be so proud of yourself if you remember the rule and you get to this, and then you realize I've got to simplify this, and then if you make a mistake simplifying it, it's going to be different from the book answer. But I'm going to leave the denominator alone. They usually will leave the denominator alone. So what would you say is a good final answer? X to the fourth? That wasn't terribly bad, but you could see how they could get bad. All right. Okay. What if they ask you the same questions they asked in the last section, but using these new rules? 36. Find the derivative and evaluate at a given value. Says f of x is 2x plus 1 over 2x minus 1 at x equal 2. So we get one more shot at the quotient rule. Denominator times derivative of numerator minus what? Numerator times derivative of denominator over what? Denominator squared. Actually, this isn't too bad, is it? Is that right? Is it negative 4 over 2x minus 1 squared? Negative 2 minus 2 more? Okay. At x equals 2, what is f prime of 2? What if I put 2 in there? Do you agree with that? 3 squared is 9 downstairs. So would you tell me in a later problem that the slope of the tangent is negative 4/9 when x is 2? When x is 2, the slope of the tangent is negative 4/9? That's what they asked me to do in 46. Find the equation of the tangent line to the graph of f of x at the point 2, 3. So let's try that. It says f of x is 3x over x squared minus 2 at 2, 3. And we've got to find the equation of the tangent line at that point. Well, to find the equation of the tangent line, I need the slope of the tangent, which is found with f prime, right? Is this starting to be memorable now? Quotient rule. 3x squared minus 6 minus 6x squared. Bless you. When x is 2, what is this derivative going to be? What is f prime of 2? Is that going to be 12, negative 12 minus 6, negative 18 over 4? Is that right? If I plug a 2 in there, is that what we get? And that reduces to negative 9/2. So now can we use that point and write our equation of the tangent line? Y minus y1 equals what?
Negative 9 halves times x minus 2.
Yes. Y minus 3, negative 9/2 x. What's the constant when I distribute? Yes. So y equals negative 9/2 x plus 12. Do you agree with that? And there's my. Just what we were doing in the last section, but now we've got some harder derivatives to find, right? We've got product or quotient rule. Another pretty good question is 52 that I picked out. 52 says, concentration of a certain drug in a bloodstream is given by the function c of t, 0.2t over t squared plus 1. Find the rate at which the concentration of the drug is changing with respect to time. What are they asking me to find in part A? Yes, c prime of t, the derivative. Well, we're so tired of doing the quotient rule now, but that's just 1 or 2 minutes. What does the numerator turn into? Yes. The book might even factor out the 0.2, but I wouldn't make you do that. All they're asking me to find in part B is c prime at certain values of t. How fast is it changing at 1/2 hour, 1 hour, and 2 hours after the injection? Why don't we just do 1 and 2? After 1 hour, how fast is it changing? If I plug 1 in there, is that 0? Negative 0.2 plus 0.2? So after an hour, it's neither increasing nor decreasing, it's leveled off. But what happens after 2 hours? Would that be negative 0.6 over, is that right? Is that right? Negative 0.8 plus 0.2. Give me the decimal for this on your calculator.
Negative 0.24.
0.024.
Yes.
Approximately. Or is it exactly? Is that exactly?
Exactly.
No dot equals. Okay. So this makes sense, doesn't it? After an hour, the concentration's leveled off. It's not increasing or decreasing. But after 2 hours, what's it starting to do? Starting to decrease. We hope that's true, right? I bet up to 1 hour, I bet at a half hour it was increasing. But we were too lazy to put in 0.5, weren't we? I didn't let you do that, did I? But I bet it would have been increasing, then it leveled off, then it was falling. And that makes perfect sense, doesn't it? Especially if you looked at the graph and saw what was going on with that at 1/2, 1 and 2. So, okay? Are these bad? Are these questions too bad? If you know your quotient rule, it's not, is it?
Too bad.
Okay. 60 is the last one in this section, I think. 60 says, the total worldwide box office receipts for a long-running movie are given by this function, T of x, 120 x squared over x squared plus 4. Okay. T of x is in millions of dollars, and x is the number of years since the movie's release. How fast are the total receipts changing 1 year, 3 years, and 5 years after its release? What do you think? After 3 years of movie's release, what do you think is happening to its intake of money? Probably decreasing unless they release some deluxe DVD or Blu-ray, right? Then it might shoot up. But if they're just talking about box office, it almost would drop to zero, wouldn't it? I would think. Or fall drastically. Well, Star Wars will probably still be making money. But let's see. It says, how fast are the receipts changing? Well, I need to find T prime. And once again, you're going to know this so well, aren't you? Denominator.
I forgot the first
Is that it? Yeah. Denominator times derivative. Numerator minus numerator times derivative. Over same old thing. Okay. So we've got 240x cubed minus, what's that? Plus, thank you, minus 240x cubed. I like that. Do you like that? That's nice, if you do that right. Over x squared plus 4 squared. So we've got 960x over x squared plus 4 squared. They said after 1, 3, and 5 years. So T prime of 1, 960 over 25. Say that again. 38.4. And wasn't this in, did it say in millions of dollars per year, I guess it said? Yeah. Box office receipts. T of X is millions of dollars. So 38.4 million per year. If I plug in 2, I get say that again? Oh, 3. They wanted 3, sorry. 3. If I plug in 3, what do you get? Was that the whole thing or just the numeral?
That was, that was not
The numerator is 3,800.
2880
116,
over,
116.
yeah, 13 squared. Yeah.
17,
What'd you say that was?
17.04. Or 17.
Approximately 17 million. Well, what do you notice? At year 3, it's more than half, right? Which makes perfect sense. Okay? And then I guess at 5, it's going to be even lower, right? I won't make you do that. But you know, if you put a 5 in there, that's even going to be smaller than 17. So the receipts are falling years after it's released, but it's still making money. Worldwide, it said. So maybe it wasn't released in China until the 3rd year. We don't know. You know, sometimes we don't get foreign movies for a couple of years, right? You notice that? It's released maybe in France, but not here until 2 years later. These are the ones I want you to try. From this set, page 177, I just said 1 through 25, every other odd. Then 35 through 41, odd. And then 45, 53, 55, and 59. Those should be clean. Those are the ones I would find important from that section. Otherwise, some of the quotient rule problems get really crazy, hard to simplify, and I won't make you go through that. But these would, if you can do those, you're in good shape. Make a note that even though we're going a little further in our notes, your quiz Wednesday is just going to cover what I assigned from 2.6 after our test, 3.1, and 3.2. What we're about to do now is not going to be on the test of the quiz Wednesday, but we're still going to have a little time to go over it. Okay. What if I told you this? On page 189, we've got another rule. Think about what we've done so far. We've done the power rule in 3.1, right? We did product and quotient rule in 3.2. Now, what if you had a function like this? And don't write this down, just look at it. What if I gave you, if I said find f prime of x, would most of you say, well, I don't know, I guess I have to distribute it out, multiply it by itself, and get a big polynomial and decrease the power? You don't have to. We have what's called the chain rule that will help us evaluate that derivative. Because you see what it is? Isn't this sort of like an inner function raised to that power? So there's an inner function, and then the outer function is like u to the 3rd power, isn't it? You look at that like inner and outer? That's the inner. The outer is u to the 3rd. Well, this is what the chain rule says in order to find the derivative of something like that. It says it doesn't want to come up with this. Isn't that just obnoxious? I don't like being slowed down. Jesse knows that from me. In the morning, it just doesn't want to wake up. It sees this was off. It's 15 minutes to noon. I guess I should test it. We can line up to punch the computer. How about that? Just like you did. I would give it a pass. Let's see. Here we go. This is good. This is great. Of course, this looks like a lot of notation, doesn't it? What I'm saying is, if you have a function, h of x, where there's an inner function and a big outer function, like I just showed you and erased on the board, this is the way we'll find the derivative of it. The derivative, if you have an inner and an outer function, you take the derivative of the outer function times the derivative of the inner. How's that? To simplify. See, f is this outer function, f of g of x. If I take f prime, that's like taking the derivative of that u to the third I was talking about, right? Derivative of outer times derivative of what I had circled in the middle. If you do that, you've got the derivative of that entire function. Okay? And here's another way to say it. If you have a function, y equals something, function f of x or y, you can say it's the derivative of y with respect to that outer function u times the derivative of that inner function u with respect to x. And if you make the product of them, that is the derivative of the thing. So what are the major words here? Derivative of outer times derivative of inner. If you can remember that, that's the chain rule. That doesn't sound like what I wrote there, does it? But it is. Derivative of outer times derivative of that inner g of x. Look how easy it's going to be to use them. What if I gave you, for instance, what if we tried number 6 on page 181? Number 6 says f of x equals 3 times x cubed minus x to the 4th power. If I want to find f prime of x, what's the derivative of this outer function, 3u to the 4th? 12u to the 3rd. Well, I'm just going to write that x cubed minus x instead of u. Okay? I'm going to say the derivative of the outer is 12. It stays the same. And drop that by 1. Times, what's the derivative of that inner function? Derivative of outer times derivative of inner. That's not bad, is it? You just have to leave what's in the parentheses alone. That stays the same in that first step, because the outer function was 3u to the 4th, this being my u. But I'm not going to make you write it as a u. I'm going to just say, leave it alone. So this is derivative of the outer function times the derivative of that inner function. And I wouldn't want to expand that out. Hopefully your book will leave it like that. I'm hoping. And if they don't, I would accept this. This is what I would want for your answer. Yeah. That's an easy one, isn't that? Could you tell me what 8 would be? Let me give you a minute to try 8 by the chain link. Tell me derivative of outer. Yes. Times the derivative of that inner. Yes. Now the book might be inclined to drop this to the denominator and make it look a little better. So they might say f prime of t equals negative 3 times 4t plus 1 over 2 times 2t squared plus t to the 4th power. They might be inclined to write it like that. If I drop that negative 4 to the denominator, negative 4 power. Would that confuse anyone? Is that okay? But to me, this is fine. But you would agree with me that if you wrote it like this, wouldn't this be easier to plug t into? Probably. If they said t is 1, to plug 1 in there, and that's 2t squared. Yeah, that's right. That's right. Good. Yeah. Very good. What do we call that again? Chain rule. Inner function, outer function. Derivative of outer times derivative of inner. I think an interesting one is 14. F of x is this, square root of 2x squared minus 2x plus 3. What could I do to rewrite this just as a power? Yes. 2x squared minus 2x plus 3 to the 1/2 power means square root, doesn't it? That means the square root of it. So if I said find f prime of x, do the outer using this, what would come in front? 2x squared minus 2x plus 3 to the, yes. If I subtract 1 from that power, it would be negative 1. Well, if the book wanted to be, clever about it, they would drop this down with the 2 and put the radical back. Because see, if I drop this down, it would be 2 times that to the positive 1/2, which means square root, doesn't it? So you might see this in the answer section. But this is fine also. Good. All right? If I drop this 1/2 power to the denominator where it belongs, a 1/2 power is a square root. So I can write it like that. Okay.
What is the final answer before?
Times. Good. I got so focused on that power, didn't I? What's the derivative of the inner?
4x minus 2.
4x minus 2.
So I just put 4x minus 2 on there.
So they would put 4x minus 2 up there. And what else could they do?
Take out the 2 so it would
Take out a 2,
just be 1.
2x minus 1, and that would cancel. If I factor a 2 out, that would be great. 2x minus 1 over 2x squared minus 2x plus 3. Good. Very good. Just wanted to see if you catch that. All right. Chain rule. Derivative of outer times derivative of inner. Okay. I'm not going to make you do 20, but if you look at 20, do you see that that's 4 over cube root of 2t squared plus 1? How could you write that as a power? And since it's in the denominator, what would I put? What's that? 4 2t squared plus t? This is what you would have as your function, wouldn't it? Instead of the radical down here, you'd bring it up as a negative, and 1/3 would be that cube root, wouldn't it? So then you could do your outer and inner. Okay. As you move down the page, you see there's a lot more of those, and unfortunately, they start to mix the rules up, don't they? Do you see in 32, you'll have to use the chain rule within the product rule? There's a product of 2 big functions. And so if you said derivative of first times derivative of second, remember product rule, beginning of the period? You'd have to use chain rule to get derivative of that function. All right? And second. So they're trying to throw them all together. Do you see in number 41, you have to use the quotient rule, but there's chain rule within it. How's that going to be when you get to something like that?
Which one do you use first, the quotient or the chain?
As they happen, let's do one. I was trying to think which would be the best one to look at. How about we try, why don't we try 40? Would that be a good one? Forty says g of u is 2u squared divided by u squared plus u to the third. Now you see, obviously that's going to be a quotient rule, right? Because it's a fraction. Well, let's just go for it. Using the quotient rule that we know so well by now. Denominator times derivative of numerator minus numerator. Now, here's where we go. What's derivative of denominator?
3. That thing to the
3.
second.
Yes. 3 u squared plus u squared times what?
2 plus 1.
Isn't that crazy? 2u squared times the derivative of denominator, which is outer derivative times derivative of inner, over what?
U squared plus u to the 6.
If I square that third power, that would be to the 6, wouldn't it? That's not pretty, is it? Aren't you going to just be so upset if the book gives some simplified answer? And you know what they probably did? They probably did some factoring. I bet they called this 6u squared, and then they looked at this, and they looked at this, and they factored out u squared plus u to the second power. They started factoring the GCF. And that's going to just completely turn you crazy. But we could do that, but I mean, what do you think then? I mean, look at this. 4u squared plus u cubed minus, now I would say 6u squared plus u squared times 2u plus 1 over u squared plus u to the 6th. Now, I bet you all see what the GCF is between these two terms. They share a 2 and a u outside, and what else? A u squared plus u to the second power, right? Couldn't I take all of that out? You just have to tell me what's left. If I take this out of that, what's left?
2.
A 2 and u squared plus u, right? Minus, take this out of that whole thing and tell me what's left. 3u outside. The whole u squared plus u squared cancels. And I still have the 2u plus 1, over u squared plus u to the 6th. Do you see now that I've factored that out, I can cancel 2 of these out, leaving how many down here? A 4. If I cancel out 2 of those in the parentheses, that would leave 4 of them downstairs, right? So I have this, it's a little better. 2u times 2u squared plus u minus 3u. 3u, 2u plus 1. In brackets, over nothing. Over, no, u squared plus u to the 4th. That looks a little better, but not a lot. Then they might distribute in the brackets and simplify further. You see where I'm going with that? I'm saying that that could go on all day, couldn't you? You just try to make it usable. What if I said plug a 1 into your derivative? You don't want to plug 1 in here. You'd make a mistake. I would make a mistake. But if you simplify a little bit, it's easier, it's fewer places to plug them in. Okay? I'm just trying to make a point about how you'll see answers in the back. You'll think, I don't know how to do this because I missed every one of them when I did the answers right. You probably didn't miss them. You probably got this right. You just didn't simplify. You see what I'm saying? Okay? That's what to expect when you do your homework. And if something really doesn't make sense and you can't see how they got from one to the other, we can try to work it. I don't like spending a lot of time just simplifying. If you know that this is quotient rule with chain rule embedded within it, I'm happy. Like if you showed me you knew how to get that step, you know how to find the derivative. The rest is just algebra. Okay?
That kind of problem makes me wonder.
Makes you
Who had
wonder.
the time on their hands to figure all this out, and why?
But it's just
why.
it's just the efficiency. Could I make that answer more efficient? And you could, but it takes your time up. So it's a balance. You have to decide what you're willing to do. And I don't want to hear your answer as to what you're willing to do.
My next question would be, where is this going to apply in a business scenario?
I'm so glad you asked that. What a nice segue.
Like real life scenario.
Yes.
And how often is it used?
Okay. I would like to show you number 68 to answer that exact question. I promise I didn't plan him to say that. I didn't tell him.
No, this is math in general. Like, you start thinking about it, it's like, why am I doing all
I know. I
this? Am I
know.
really going to use this in life?
Yes. Uh-huh. Why is it in this class, right? How about this? 2003, the number of U.S. jobs that are projected to leave the country for outsourcing, right, corresponds to this function. N of t equals. And this is real data, right? This is not just made up. 0.018,425. That looks real, doesn't it? They told me where they got it, though. Source, Forrester Research, right? T plus 5. We trust Forrester Research, don't we?
I don't know who that is.
It's not good.
2.5. And they say for years between 0 and 15, from year 0 to year 15. That's when that function's good. Okay, look at what the question is. How fast was the number of jobs that were outsourced changing when t is 5 and when t is 12? Assuming 0 was 2000.
Can't we just plug 5 in?
Well, how quickly was it changing? I have to find the what? Oh, and if we didn't know the chain rule, we would be up the proverbial creek, right? Right? I couldn't do that. But now that we know the chain rule, what is it? It's easy. What's it going to be?
This 0.00460625.
Say that again. 0.
0.0460625.
Times t plus 5 to the what?
1.5.
Ah, good. And what's even the bonus to this one? What's the derivative of n? 1. Makes it no worse, does it? So, if I want to find how quickly the outsourcing was changing in year 5, in 2005, I just plug 5 right in, and I use my calculator to get what that value is. Let me do that on mine while you do it on yours.
I'm not getting the same
Oh, you're not?
decimal number.
0.001845 times 2.5. 0.046,125.
That's what I'm reading.
Is that right?
I put a 2 on
Thank you. Okay. If I put a 5 in for x, for t, 10 to the 1.5 power times 4. Is anybody getting 0.145868? Does anybody agree or disagree? If that is in millions, what is that number?
145.
Yes. If you multiply this by 1,000,000, it's 145,860 jobs. What would that be per year? That's the rate of outsourcing in 2005. The outsource is increasing by 145,860 jobs per year. You know what? The reason I got the different answer than what they have in the book is I wrote this function wrong. This should have been 2.5 or something like that. But for what I wrote, we got the right number. Does that bother anybody?
Yeah, that's how I got that.
That's how he got it right.
It's numbers and
He was
Yeah.
right.
That's
So
fine.
all that data is wrong. That's like that
the
comes
numbers
back.
are wrong.
If you wrote down my wrong function, you got
That's right.
a certain answer. He looked at the book like he was supposed to.
I got one for the final answer right there. I got 1.458660 because I believe because you put 1.5 as your exponent
Mhm.
right there
Yes.
instead of 2.5.
Well, didn't we have to subtract one though?
Just subtract.
Oh, okay.
Had to subtract one. Remember, chain rule, derivative of outer.
Oh, okay.
Right.
Okay. Yeah.
There you go. Very good. See, we all had a few minor errors, except for those two over there. Okay. But yeah, but you see what we're talking about. And if you put in year 12 here, you would get a different number of outsourcing jobs per year, a different rate of change. So, did I answer your question about how we would use this in the real business world? No comment.
It's harder to see like right here. I mean the concept's real, but
But you know, in economics or anything in business, you're going to have functions like this out the wazoo, aren't you? And if you have to find rates of change, that's what we're learning to do.
I guess it depends on where you are in that.
Yes.
And your quantity over price can be.
And when you get to that, if you're not there yet, you know how. They'll say, well, what's the rate of change? You said, oh, the derivative. I know how to do that. I remember. You're going to all say that, aren't you? I remember. I can do that even 3 years later.
I
I
got
did it at
this.
one point.
I did it at one point,
I
yeah.
got this.
70 is a pretty good one.
No, that's-
I like 70. I will write down the right numbers. This function is a of t equals 699 over t plus 1 to the 0.94, if that is good. They say this time for years between 0 and 5. T equals 0 to 5. That's good. This is the average selling price of a standalone DVD recorder. How many of you bought a DVD recorder when they first came out? Weren't they like $1,000? It was ridiculous. Now they're $150. You know, I love it. And you can copy them on your computer probably with a program for nothing, right? We won't admit we do that, but you know. Let's see. It says, how fast was the average selling price of a standalone DVD recorder falling at the beginning of 2002 and at the beginning of 2006? Well, I've got to find the what? The derivative. Yes. But to do that, how should I think of this function? I'm not going to leave it like this because I don't want to do quotient rule. How can I bring this up as a power? Negative. 699 t plus 1 to the negative 0.94. Just bring it up as a negative power, then you don't have to use quotient rule, do you? Because would you rather avoid that if you could? Or do you like it so much you would rather use it? Okay. Oh, yeah. And we'll have to do chain anyway, won't we? Within quotient or power. Okay? So help me do this. If I use this form of a of t, what's the prime going to be? If I bring the negative 0.94 in front,
Negative 657.06.
like it, T plus 1 to what power?
Negative,
Negative 1.94.
Negative 1.94. I subtract 1 from it, don't I? Okay. Is that good? Okay. Good. Okay. The verifiers are checking things out.
You
That's
want it
good.
like that rather than over.
Oh, we could
X
go ahead and
plus
put it back
1.
over, but you know that's a good.
1.9.
In fact, before we plug anything in, why don't we write this negative 657.06 over t plus 1 to the 1.94. Move that right back down. That'll be easier to plug into, won't it? I think. Now look what they asked me. They said, how fast was it falling at the beginning of 2002? Now year 0,
2002.
oh wow.
So it'd be 657, 6 cents.
Yeah, if t is 0, it's just a prime of 0 is negative $657.06 per year. That makes perfect sense to me. You know why? Because what if in 2002 they charged Renita $1,000 for her recorder? The very next year, how much did it fall? Probably about $650. And it was $350 the next year. Well, did it fall more the next year? Yeah, down to probably $150, didn't it? Well, let's see. What was the next value? It said
2006.
2006, so that would be year 6. Year 4. Let's do that. A prime of 4. If you plug 4, that would be 5 to the 1.94. Let's try that. Did you get negative 28.94? 95? You ready? Now think about why that would be true. What if it fell by this huge amount the first year, then in the next few years it maybe fell another 150, 100. By the 4th year, it's only falling by about $29. That would make sense, wouldn't it? It's not falling that fast anymore because it's already fallen so much. Pretty soon it's going to get to the price that it has to stay because the materials need it, right?
New technology.
Yes. Just think, what if we can buy a 70-inch HD TV in a few years for $150? Wouldn't that be great? Love it. You know? But by then, there'll be something even better, right?
We don't even want that anymore.
Right. You'll want something else. Have I convinced you that you might need this for some economics? No.
no.
Oh, no.
Well, if you want to be a teacher one day,
I did my best. If you want to be a teacher
Yeah,
someday.
Yeah, thank you.
No. Rate of change. This is interesting. This is real. Real.
This is not going to help me in my degree.
you'll be okay.
It will help you get your degree.
It'll help me get my degree, but it won't help me in my, well, it'll help me in this degree, not
Yes.
my other degree.
Yes.
Machine
Well, it
code
depends on
chain
what that
effect.
degree becomes, though. You know, what if you decided, I love this so much, I'm going to be a math major
That's a big what if.
now? Somebody told me last week, one of the tutors,
Yeah, I know you're talking
yes. Yes, he came by and he said, I've changed my major to math. And I was like, all right.
You might have a better chance of winning the lottery.
Oh, no.
No, you don't.
No, it's good.
No. I work retail. I know what that is.
Let's see if there's anything else I need to mention about these. Remember, this is just going to be to work on for homework. This is not on the quiz Wednesday. This is just so we're moving ahead. So it'll be on the quiz after this one. These are the ones I'd like you to try. On page 189, 1 through 49, every other odd, 63, and 67 through 71 odd. That's basically the types we did. And these are the word problems. And those are the ones that I want you to stress and not go crazy on. But think about, what did we do today? We did 3 rules, didn't we? What were they? product rule, quotient rule, chain rule, and application. If you know the basic power, product, and quotient on Wednesday, you're going to be great on the quiz. I'm going to tell you right now, you know what the first question on the quiz is? State the limit definition of derivative. Can you all do that? You don't have to use it, but can you say this? What is it? What is it? That is the blank for number 1. So don't be surprised when you see that. State the limit definition of derivative. The rest of the time you use the simple rules we came up with, but I just need to know that you studied and know what that rule is. Okay?
Well, how is it simple?
Well, mostly, I mean, think about this. What if I said, what's the derivative of that?
You got
3x squared. That is a simple rule.
Well, if you have them all like that, all like
Well, variations on that. But I think this will be an easy, good grade, hopefully, on this quiz. So we will go a little further in the notes and take the quiz on Wednesday, and then we got a holiday Monday, don't we? Already another. So.
All right, my guys. See you.
Tomorrow morning.
Oh, yeah, we got test.